Hey, so let's talk a little bit about um, curved mirrors. I'm going to post this into our chat. So curved mirrors are the easiest way for me to start talking about them is diverging and converging mirrors. The reason why I want to use that versus concave, diverging mirrors do the same thing as diverging lenses. And converging mirrors do the same thing as converging lenses. They bring the light rays to one point. Or if it's diverging, they spread them out. Now, the problem with it is when we talk about the verbiage, the shape of the mirror itself, concave is going to be diverging. Convex is going to be converging mirrors. When we talk about lenses, those are swapped. So it gets confusing. Okay, so I'm going to focus on mirrors today. Next week, I'll make another one of these live streams and we'll talk about our lenses from that and refraction. Actually, we'll probably talk about refraction next week, then lenses the following week. All that being said, the idea behind a curve lens or curved mirror, is that it's producing a virtual or a real image. Okay, and the converging mirror will produce a virtual and look down in the mirror and you can see the image that's inside the mirror, right? Like if you go an image in there, that's what we mean by virtual. A real image is going to be one of those that is populated out into some on a projection, and we project out onto a screen and we can watch what's happening in the movie. That image is produced inside of, or the object or light is inside of the projection, and it's then through a lens makes it really big out on the wall. Okay, produced in space. Okay, I can also produce an image, and give me just a second. Sitting here, I can get this out, produce an image like this with a curved mirror. So right here, you can kind of see I have a little pull rock, and then I put that on there, and we can make the pull rock, if I get the right angle, look like it's right up here. Right. I know it's not perfect for you guys because as I move this, the pull rock moves, right? And so I have to kind of keep it nice and level. Maybe if I turn your image this way, you can see it kind of produced right here. That image is up in real space. You can see the pull rock is actually down there. So it looks like the pull rock is right here and I could just touch it, but I can't because that image is in real space. Okay. And if let's see if I can do this. I'm going to keep my eyes, use a little law of reflection, get where I can see it. And then you should be able to see it in between. There it goes right there. You can see it right there. It looks to me like it's right on top there, but it's actually down in bottom. That's an example of making a real image. Okay. Now, if I look in here, I can see what's the above. You see all the stuff above my roof inside of here. I can see my fan spinning in there, that type of thing. That is a virtual image. It is inside the mirror, right? It appears as though it's in the mirror. So a concave mirror can produce a real image, which I showed you here, right? When I did this, that's a real image, or a virtual image, right? As we see back inside of that. A convex, which would be bending the other way. So see how this is caved inward? Caved inward. that means concave lens, right? I'm sorry, concave mirror. This is a mirror. Concave mirror, okay? If it's bulged this way, if the mirror, this was the mirror surface and it was curved this way, that would be convex. Now, what's happening with this, the concave is converging the lights on mirror is converging the light to one spot, and we're able then to get that real image, right? That's where that image is converging. The convex mirror would diverge. As the light comes in, the light rays bounce outward, away. Diverge would be away, right? And so the convex mirror is going to be diverging mirror. The concave mirror would be converging because it's going to bounce the light rays to one spot. I hope that makes sense to you about the differences. Now, let's talk a little bit about finding the image. So right here, when I'm looking at this guy, they had to build this in such a way where they were able to produce the image right at the top, or it wouldn't be as like we try to have to find the image way out here, right? Depending on how the curvature of the mirror. So to find where that image is, there's a specific equation. And let me kind of show you what that is, if it'll let me switch my camera. Oh, I don't have access to switch the camera, maybe not. Oh, I'm not going to be able to. Okay, that's all right. I'll write the equation down and then show it to you. So the equation to find where the image is, find image in mirrors. We'll say curved mirrors, because where the image is located in a flat mirror is the same distance away that the object is. So we have the focal length of this curvature of the mirror. That's what F is going to be representing. So F is the focal length. Focal length. Now, focal length, it just basically has to do, focal length just basically has to do with the curvature of the mirror. Curvature of mirror. It's going to have a different, the more curved it is, the focal length will be different. The less curved it is, the focal length will be different. Okay, there. And then that's going to be equal to 1 over the object distance plus 1 over the image distance. And so most of the time, you're given the information about the focal length. So you're going to know the focal length. You're going to know the object distance, how far away it is from the mirror. And they want to know, find where the image is located. Okay. So P is going to represent object. P is object distance. Object distance. And Q is image distance. Q is image distance. Okay. Take a little moment to pause the video and jot down some notes. And now we're going to write an equation solving for Q. That's going to be the key thing here, solving for Q. To do that, we need Q by itself. So because we're adding 1 over P, I'm going to subtract 1 over P from both sides. Hope that makes sense to you. Subtract 1 over P from both sides. So minus 1 over P. And I get 1 over the focal length minus 1 over the object distance gives me 1 over my image distance. So I get that. Okay. Of course, it would be minus 1P goes away, and I get that. Okay. Now, this guy here is 1 over Q, but I need Q. So I'm going to get the inverse of this function. To do that, I'm going to put this to the power of -1. Whatever I do to one side, I have to do to the other. Okay. Now, 1 over Q to the power of -1 gives me Q. So I can just rewrite it as Q is equal to 1 over the focal length minus 1 over the object distance to the power of -1. That's going to be the equation, and this is very important. If you're solving for the image distance, whether it is a curved mirror or a lens, that's what you're going to use every single time. So this lesson about curved mirrors, and then you get to lenses, you're going to come back to the same equation. So don't forget this equation. Now, if I want to know the focal length, I got to do the version up on top. So the focal length version of the equation is actually going to be focal length is equal to 1 over P plus 1 over Q to the power of -1. And I got a little crazy with my -1 there. I apologize. So it's going to look like that for the focal length. So this is for the image. That's the focal length. Now let's look at what would be for the object distance. So P is equal to 1 over F minus 1 over Q. And maybe make sure that that's an F to the power of -1. So these are the three equations you're going to use for lenses and curved mirrors. If we're trying to find the focal length, if we're trying to find the object distance, or if we're trying to find the image distance. This is the number one equation that we typically use. We want to find where's the image going to be located when we're dealing with these three variables, the focal length and the object. The variable would be the image that we're solving for. So this is focal length. I keep writing in focal length. This is object distance equation, object distance. And then this is image distance. Okay. Take a moment to pause that real quick. And that's 12 minutes of me kind of talking you through what curved mirrors do. Now, keep in mind when we're looking at curved mirrors, there are certain things that we're wanting to use them for. So if you need to widen your vision, you want to see around corners, you want to see more things, then you're going to have more of a convex mirror. Okay. I want to see around a corner. So you're going to think about being in a grocery store and those mirrors that bulge out at you. Now you can see around a corner, which you wouldn't normally be able to see. Okay. The purpose of that is to widen your view. That's why we would use a convex mirror. If you're looking at a concave mirror, one of its good purposes is when you bring it up really close to you, it is magnifying, right? And so we actually magnify. If I bring this up really close, you can see it makes images really big, right? My door back there gets much bigger. Let's see if I can line it up right so y'all can see it. Or the webcam gets bigger, right? Look how much bigger that webcam gets. You get really close and things start getting really big. And so a concave mirror is used to kind of help us zoom in. If we're trying to see a specific spot on our face, right? We're going to zoom in on that spot using a concave mirror. So that's one of the benefits of a concave mirror, is you can actually zoom in, make an image much bigger so that it helps you out. I hope that makes sense about your curved mirrors today. Hopefully we gave you a little bit of help. This video, sometimes people just need to see the things going on. If anybody, it looks like I may have had one person join. I don't know if you guys are able to chat. I thought I started it off where you can chat, but thank you for coming today. I would like to know if you did come, was there anybody that, can you chat with me? Can you go to maybe the physics chat or go to Google Chat, send me a message if you're one of those people that are watching with me right now? Somebody popped in and gave me a thumbs up and then bailed out on me, I guess, because they couldn't communicate. No stress, though. Thank you so much. I want to keep trying this out and trying to figure out the best way for this to work. I like doing live streams like this where I can just talk about the physics content and you guys can have a video afterwards and then also talk to me during. I hope these things help you guys out. Give me some feedback via chat or Canvas message text message if these things are something you would like me to keep doing, or if you are benefiting from them. Thank you so much for your time. We'll talk to you later. Keep being curious. Think about mirrors and around you, curved mirrors around you.